The FFL method is a semi-advanced method for the Pyraminx. In this video, I'm going to go over what it is, talk about whether you should learn it, and show all the algorithms you will need to learn. The FFL method has two steps. The first step is the same as the first step in layer by layer, but with one major difference. With layer by layer, you make a layer with all the edge pieces having to be in the right place and oriented correctly. For the FFL method, the pieces still have to be in the right place, but they can be oriented incorrectly. So you can have a layer with one, two, or all three of the edges flipped. The second step is to solve the rest of the Pyraminx with one algorithm. Basically, FFL is layer by layer, but with more algorithms and more freedom in the first step. So, should you learn FFL? Well, if you want to learn this method as your only one, don't. It's not very good as a standalone method. You should only learn this if you already know an advanced method like L4E and want to learn FFL for the rare occasion that you get a scramble that is really good for FFL but not L4E. This method is more of an addition to your knowledge or a tool that you can use every so often rather than a proper usable method. So if you already know an advanced method and want to learn this one, let's get into the algorithms. The first set of algorithms are when there are no pieces in the bottom that are flipped. But these are just the last layer algorithms, so I'm not going to be going over these in this video. The second set of algorithms in this method are when there is one piece in the bottom that's flipped. Now, this is just a part of the L4E method, so again, I'm not going to be going over these in this video. The first set of algorithms that I'm going to be going through all have two pieces on the bottom that are incorrect. And with all of these algorithms, you hold these two pieces to your right with the correct piece to your left. This is the first case where all the pieces on the top need to be moved around to the right. Or if you're looking at your front color, then those edges are on the left. So the algorithm is this is the second case, where all the pieces on the top need to be moved round to the left. Or if you're looking at your front color, then the front color edges are on the right. And the algorithm is this is the third case, where there's one piece in the top with nothing correct, and then two bars pointing down to the right. And the algorithm for this case is this is the fourth case, where there's one piece with nothing correct, and two bars pointing down to the left. And the algorithm for this case is this is the fifth case, where there is one piece with everything correct, and two pieces that are in the right place but flipped. And you don't really have to learn a new algorithm for this. You can just turn the Pyraminx, and it's a L4E case now. The last set of algorithms that I'm going to go through have three edges in the bottom that are flipped. And for all of these algorithms, you can hold the bottom any way you like, because it's all the same either way you hold it, because all three are flipped. This is the first case, where you have two pieces where nothing is correct, and you have a bar pointing down to your right that you want to hold at the back like this. And the algorithm for this case is this is the second case, where you have two pieces where nothing is correct, and you have a bar pointing down to your left that you want to hold at the back here. And the algorithm for this case is this is the third case, in which you have 3 bars that are all pointing down to the right. And you can hold the top and bottom any way you want. So like if I were to do that or that, it doesn't matter. Hold it any way you want. And the algorithm is this is the fourth case, where there are 3 bars all pointing down to your left. And you can hold the top and bottom, again, any way you want to, so I can do this as much as I want. And the algorithm for this case is this is the fifth case, where all 3 pieces in the top are flipped and in the right place. So all of the pieces on the Pyraminx are flipped, but in the right place. Now, with this one, you can hold the Pyraminx literally any way you want, like any way. And the algorithm is nice. You've done the method now.